Hi everyone. Today's session is about um, process, process and threading. If you know, in OS there are processes and threadings. Process is like browser. If browser we open like Chrome, it is a full process exe and it uses a lot of uh, you know services like it uses stack, heap, or registers or code segments, data segments. But the difference between the processes and threading is one process use no multiple processes use same stack and registers, but in threading every thread has its own stack and register. So when we use threads, it divides that particular task of that process. Like if we open Chrome, it is a process. But when we open new tab, it creates one thread with its own stack and own registers. So it makes it more fast to operate and make its data separate. So no any kind of interrupts will happen when it performing something. Like when we are browsing somewhere we playing a song in YouTube. So it works because they use threading. So same like that. First we're going to experience how threading works. So if you know basic Python, so it is basic Python we importing threading and using a time to calculate how much time it takes. So sleep means it's going to stop the command line execution for 2 seconds and it is a for loop for 5 seconds. It is first function is print numbers and second is print letters. Basic function A, B, C, D, E, and there are 0, 1, 2, 3, 4 going to print. So if we print it directly, it's going to delay every 2 seconds. So if we calculate, it going to take 20 seconds. But if we use threading like this, threading dot thread and target is equal to prime numbers. Target is equal to print letters. So we created two threads using this function. So what going to happen? We're going to start these threads and we're going to end these threads at the same time. We're going to wait to complete all the threads with join. Join actually joins all the threads and stops when all the threads joins. Okay, and it is a basic code. Start means time means it gives time dot now kind of thing. That particular time of system time. It is not like our clock time. System time is always incrementing, so it uses it has to be t, and when execution ended, it minus that at that instant time and that we created time, so we can calculate the difference between execution. Okay, it is simple. So we will first execute and let's try it. Multi-threading. You can see these two functions running simultaneously together. Their their for loop is actually running simultaneously at the same time. So it going to give us a 20 seconds, but now it is 10 seconds, so it is efficient. We make it scalable. Okay, it is the use of multi-threading. Next is multi-processing. It is multi-processing. Same like that, just a function difference is square and cube. We perform in here cube and here is square. Okay, same like that. Just the difference is we have to use this you know convention of we can't um import these processes. So this statement means we can't import P1 and P2 to any file, but we can only use it in only main file. This is its main file, so it can only use here. So we created process 1, process 2, like threading, multiprocessing dot process, target and functions. Okay, time is that instant time. After that, we going to perform a functions after instant time minus that previous time. So same like before. Okay, this is going to work like this. Working same, but the difference is in one we have 1.5 delay and one have 1 second. So I'm just showing you it actually works same, but it is running in separate way. Okay, in separate processes. Process are different. They're using different heap and everything. Okay, now I'm going to show you the pooling. Actually, main concept in machine learning and deep learning, they use pull to execute some kind of operations. If I give you example, there is one project I did about extracting code out of video. Some kind of as I am giving you this video and I have here a code, but every time I'm going to shift scrolling, so you can't actually type that code that fast as I'm showing you. So my project is can do it extract all the code out of that video. How it do it from video it converts it into a images, and one video is if it is 10 minutes then it creates its 100 or 1000 images out of it. Every second has one image. So when we going to use OCR on those images, it taking time. So we use their multi-threading and we divided count of the images in those threads in a pool. And what is going to do, it's going to create a batches like 10 images, and at the same time using 30 threads, it's going to perform 10 images. So it's going to reduce our time to operate with OCR on those images, and it's going to be a scalable. Machine learning is about scalability and giving quick results. So for that you have to understand multiprocessing and this pool execution. It is simple. Let's see it. There are functions like print number, square. Just the difference is there is not for loop. We're returning only number, which is here parameter. If you give argument here, it's going to show return the number is equal to that number. Okay. We use pull through concurrent.future, and there is third pull execution, process pull execution. Okay. If you see, if you want use, you have to use with. If you don't know how to use with, please check out any, you know, any tutorial about it. We using here thread pool. Max workers are 3, so we actually using only 3 workers, like 3 segments of that thread, and creating an executor out of it. Okay, so results going to come out of this executor by mapping function print number and going to iteratively give him a argument from a numbers. So like a for loop, you're going to give a argument 1, 2, 3, 4, 5 to print number and divide it into a threads. Simple. Okay. Like a for loop, it's going to work like a for loop, but for a function. Okay. It is same like here. Process pull execution workers are 3 and executor. So executor dot map that function and our inputs in a list. Okay, it is giving a square and it is number printing a number. This is a process. This is a thread. So let's see how much time it takes. See, quick. It happens so quick. If you can see, we don't here have 2 seconds and here have 1 second delay. That's why it is a difference, but you can check there actually 5 means it has to be 10 seconds, but it happens it ran executed in only 4 seconds, and it has 1 second delay, so it has to be 5 seconds, but executed in 2.2 seconds. That's the power of pulling. Okay. If you want to see any use cases as I practiced here some use cases. Let's see those. Real-time execution in web scraping. Web scraping also part of the machine learning. You have to collect a lot of data. Um, it is related data where some website have data, like if we consider admission related data. So if I want to create one machine learning model about telling me if my application of abroad MS admission is going to selected by that particular uh, university or not. So we have to first have to collect the data for what kind of applications and what kind of details are rejected or accepted from universities, lot of universities. So there is one website, I don't know name right now, but I collected that data for one internship and gave them to use that data for creating a machine learning model so they can implement in their admission related portal. So web scraping is important. So if we have to make web scraping more efficient, so we have to use threading. So you can see here, it is a fetch component function where we are fetching using a beautiful soap. We first requested to get URL, which is going to pass here with a parameter, and soap is equal to beautiful soap. Soap is not anything, it is a variable name, but a beautiful soap is a function where we're going to get that response out of this request, response.content, and convert it into HTML. HTML means we just creating that HTML into uh, text. You can understand it. You can't use div as a text for your extracted data. So we just parsing all the HTML from it. Okay. And there are threads we're going to append. Here is a for loop for URLs here. These are three URLs from langchain.com. And if you use thread is equal to threading.thread as we've seen it, target is equal to fetch content, and we can pass also argument, and this is a URL. Okay, we passing a URL by for loop, and when we adding this thread, we appending that thread into threads. Means his thread is going to be here after every iteration, and that thread going to be started. So started thread is going to be in that threads list, and if we want to stop them at the same time by waiting for others to execute, so we use threads in a for loop and join them. Same as before code, like this code, but the difference is we using for loop for this kind of operation. Okay, we don't have to always have to write two threads and then we have to stop them with code. No, we can stop with for loop as you can see here. So it also works fine. If I run it, process threading, okay, you can see output. What happened? Something is wrong. Sorry, just I'm not online that time, so it gave me error. We can perform it again. So you can see it fetched all the content and calculated the length. So this is at the same time. If you never used web scraping, you can understand, but web scraping takes a lot of time, sometimes 2 seconds if for one URL, but they are executed at the same time. You can see it, they actually gave result at the same time. Okay, this also use of, you can see a pooling also. This is same example, but there is a one different is we performing big operation. Operation means factorial. If we creating a factorial of 1000, or you know, their number is going to be really big, so calculating it actually takes time to computer, but we can create its process and separate them, and the process will manage it in a separate processes. So my computer is have 12 cores. If you, no, it is 8 core. they actually have 12 cores supported, but it is 8 core operations. So it will divide it into cores and it will give us our result. Okay, let me show you directly so you can understand it quickly. It calculated this result in this fraction of seconds. It is only a one number. You can see here. This whole result is calculated within only 2 seconds, I think. 3 seconds. Look, this is the power of process multiprocessing. It calculated these four numbers at a time. So it is a really important thing to understand, practice it, and I think I will going to use it. I'm absolutely going to use it. It I will need it. So thanks for watching, and you can comment. Tell me what kind of things you don't like about my editing. I just don't edit my videos, just record it and send online to it as a discussion. I'm not so much proficient. I'm just from CSE ML department, so I know a lot of things about web scraping, machine learning, and data processing, like kind of things. More of things I'm actually learning. So you can be part of my journey, and you know you can also learn. It is actually really good way to learn first basics, then starting the basic code. It's going to be really, boring at the start. Machine learning is looks like really easy, but it is not that easy. You will understand what I'm talking about. Okay, then bye. Thank you for watching, and not really need to subscribe right now. After 33 videos, I think I will tell everybody to subscribe.